So looking at the following, you have two different graphs here. And so you're supposed to determine which is the original function and which one is the graph of the derivative of the original function. Is it y sub 1 or y sub 2 graph? And so when I'm going through and trying to figure out which one is the function or which one is the derivative, or if I have to graph the derivative function, I tend to look at where is my graph increasing and where is my graph decreasing. I know that the derivative, and we could notation wise write it as f prime of x. If the derivative is less than 0, the slope is less than 0, then I know this is where my function f of x is decreasing. If I'm looking at my original function and I'm looking at where is my graph increasing, I know that my derivative function would be greater than 0. So f of x would be increasing, then we know our derivative is positive. So if my derivative, if it's decreasing, this has to fall, derivative function is below the x-axis. The derivative function. Where if it was, my original function was increasing, then on that interval, that's going to be the same interval where my function of the derivative falls above the x-axis. So f prime of x, the derivative function, is above the x-axis. Other things that are helpful is when it's equal to 0. So my derivative function equals 0. Then that means that the slope is equal to 0. This could be a max or a min. So, and then also if my derivative is equal to 0, what does that tell me about the function, the graph of the function, derivative function? That tells me this is the place where the derivative function is below the x-axis. Or not below, is on the x-axis. So derivative function crosses the x-axis there. So I'm going to use those facts to kind of determine which one is the original function and which one is the derivative function. So if they're giving you two graphs at once, I would just choose one of them and I would start looking at it and see if I get a contradiction. And so let's just start with y sub 1. And so y sub 1, that is the graph in here that is red. And so I notice that it's increasing, right? It's increasing until, let's say that this is a 1, that is negative 1. So we have an increasing y sub 1 is increasing on the interval from negative infinity to negative 1. And I also see that it's increasing from x equals 1 to 2. So union this 1 to 2. Well, that would tell me then that my derivative function, then y prime, y sub 1 prime, is above the x-axis. On negative 1, infinity to negative 1. So let's just look at that. Is the other graph Looking at the other graph, this is above the x-axis, but it crosses the x-axis when x is 2. So it's not all above the x-axis there. So this y sub 2 is not above the x-axis on that entire interval. So I would go back and that would tell me right now that I have a contradiction. Y sub 1 could not be the original function. So I would just go back and see, does this hold for the other function then? So it's y sub 2, my original function. So let's look at y sub 2 now. Oops. Come on. That's not. So if I'm looking at y sub 2, again, let's just look at maybe where, again, I guess we could look at where it's increasing. So y sub 2 increasing. So it's starting to increase about negative 1.5. Until about here. And then it's increasing about here to here. When we're looking at where it's increasing, we're looking at the x values where it's increasing. So those x values would be, we said about negative, let's say negative 1.5 to about 0.5. And then it's increasing about 1.5 to about what, 2.5. So these are not points, these are the x values where it's increasing. So y sub 2 increases on this interval, which means that our derivative function, so y sub 2 prime is greater than 0, which means that the derivative function has to be above the x-axis. So is y sub 1 above the x-axis on those intervals? So I would look back and see and make sure. Okay, so on this interval, notice that my graph is above the x-axis here. That's all above the x-axis. And then for this piece, I'm still all above the x-axis. So I'm good there. And that is matching. If I look at decreasing, where is y sub 1 or y sub 2 decreasing? Oops. Y sub 1, sorry about that. Oh yeah, I'm looking at y sub 2. So y sub 2 is decreasing. If I looked at the intervals there, well, it's decreasing, it's coming down, right? Until I hit that negative 1.5. So from negative infinity to negative 1.5. Is my graph of the other function below the x-axis then? So the derivative function, y sub 2 prime, which equals our y sub 1, is below the x-axis. This is below the x-axis here. Decreasing on this interval, and notice we're below the x-axis there. So union, that was 0.5 to 1.5. And then it's also decreasing my y sub 2 here. Oops, wrong one. I'm looking at one, I'm getting confused now which ones I'm looking at. So y sub 2, yeah, is decreasing here. So this should be below the x-axis the whole time. I don't know why it's not. Just pause. This is going to be below the x-axis there, this piece. Okay. And then the last thing, y sub 2 increasing, we want to look at where we have max and mins. So y sub 2, we have a min here. Notice that's where it's going to be crossing the x-axis for the other function. And it is. We have a max here. This is where the other function should be crossing the x-axis, and it is. We have original function, this one, crossing the x-axis here. We have a max here. It's crossing the x-axis here. And so our max and mins of our original function should be where it's crossing the x-axis on the other function, and that is true. And so y sub 2, it holds is our original function, and y sub 1 is the derivative function. And y sub 1 is equal to the derivative, so y sub 2 prime. So it's just kind of going through and doing some reasoning and making sure things check off okay when you're looking at which one is the original function and which one is the derivative function.